Well, well, what has the cat dragged in today? It's another ballsy tutorial. Yeah, I know, but that's not getting old anytime soon for me. But in all seriousness, let's get this ball moving. Last time we set up the physics so that way when we release the ball, it will randomly go either left or right and spin. Now I noticed that it was behaving not quite the way that I was expecting it to, in that it was really sailing off in a big way to the left or right sometimes. It was, you can see there, just like shot almost like straight left. But that's not the behavior that it had in my practice run preparing for this video. And I wanted to understand why. And the reason why I'm spending time on this in the video is I want to help you understand how even the smallest things, sometimes the smallest number overlooked, can cause a massive change in behavior in the program. And so it's very important to develop the analytical skills of going through and comparing things and just step-by-step analyzing what did I do last time, what did I do this time that would cause it to be different. And the big thing, or the tiny thing, depending on how you look at it, that I did differently is in the physics property of the rigid body, I forgot to change the mass. In my practice version, I gave the ball a mass of 10 so that it would have a little bit more weight behind it, so to speak. It wouldn't feel so floaty as it was bouncing around. Well, needless to say, an object with a mass of 10 that receives an impulse force of 25 is going to behave much differently from an object of a mass 1 that receives the exact same impulse force. And so by changing the mass on the ball to 10, it is now going to behave closer to how it did previously. You can see now that it has a much more controlled, sort of heavy feel to it, and it doesn't just rocket off to the side. So that is a very important game dev lesson there. You have to pay very close attention to detail, because even missing a small one like that can cause you a lot of headaches. This is also why, once we get further along in these tutorials, we will begin to use prefabs and macros for Bolt. So that way when I have to replicate things, I don't have to remember to go through and say, modify the property, the mass property, on 20 different objects. I can modify the mass property on a prefab and place that prefab 20 times. But enough of that. Let's get this ball moving back and forth. And for that, I got to remember, okay, that's right. Move my graph down here because I was tracing things as it was running. But let's get the graph back up here. Go back into full screen. And we're going to be working in movement today. Now, there are some things that I'm going to need as object-level variables, and there's some things that I'm going to need as graph-level variables. It's important to keep the difference between these two straight. A graph-level variable is only visible in the graph it's created in. Notice that I am now in the graph of the movement superunit, and I don't see is top. If I go to the graph of ball, there it is top. Superunit movement? Nope. Superunit ball release? Nope. So it's important to keep in mind the difference in scope, as it is called in programming terms, of your variables. Something that is scoped to the graph level is only visible within that graph. However, something that's scoped to the object level is visible to everything on that object, including other flow graphs. As in, I could have multiple flow graphs on this, and if they're using object variables, all of them can see it. Likewise, they're also visible in the inspector. So there are some things like my movement speed that I definitely want as an object level variable. So that way, if I want to tweak how fast the player can move the ball, I can just come to here in the inspector and modify the variable here, rather than having to go into editing the graph and then going into the super unit and modifying a graph variable here. Now I know from the previous tutorial sequence that I'm going to want to set up a move offset variable to determine, based on my movement speed and the input from the horizontal axis, how much do I want to offset things. That is a graph level variable. Nothing outside of this graph needs to be concerned with the move offset. As an object level variable, I am definitely going to want to put my movement speed as an object level variable, because that's something that I would want to potentially edit frequently, trying to dial in exactly how this should move. So I'm going to make that an object level. Now we're going to need some additional object levels as well, but those will come later on. Now, the first thing I'm going to do is I'm going to zero out my graph variable here. So I'm going to go into vector 3, and I'm going to use vector 3 set new xyz. I'm going to zero that out. Do I have to do this step? Not really, to be honest. But it's a good idea to start thinking in that mentality of there's going to be dirty data in this from the last frame. And so I want to wipe away that dirty data to make sure that it's not impacting my current frame, because that is a thing that happens a lot in game development. You'll have a variable that persists frame to frame, but you don't want that information to actually persist. It's just how you declared the variable. So I want to wipe move offset every frame. It's like we did last time. I am going to go into input, and I am going to get an axis. Of course, the axis name is going to be horizontal. And I am going to need to take that value. I am going to need to multiply. Actually, I'm going to need to multiply a bunch of stuff. So I'm going to grab time.delta time. I am going to grab from the object level my movement speed. I am going to multiply these two together. Which will give me my movement as units per second. Because remember, time.delta time, fraction of a second. If this movement speed is represented in terms of units per second, I need to scale it by time.delta time to make sure that I'm getting the right amount. And then I can take these two numbers and multiply them. And that's going to give me the actual movement offset that I want. And so now I can take this and add it to my transform, my position, my transform.position x value. And I'm going to set that to movement offset. So I am going to vector3.x set. What am I setting? I am setting movement offset. I could drag the wire from over there, but just to keep wires from being every which way, I'm going to drag this over here. So I had, there we go. So now I have my movement offset. Now I need to take my movement offset, add that to my position. But unlike last time in the previous project where I could be done with that, I've got to do more with that. So I'm going to save that information. So I am going to do, oops. Another graph set here. Now, and I want to set this to my current movement offset plus my position. So if I come in here and add a new unit, I'm going to say transform.position. Now I need to add these two together. Now this, I can tell by the little blue dot, is the X value. I don't want the X value, I want the transform. Thankfully, if I select vector 3 here, there is a chainable option that I can check that will expose the vector for me. So I can add them together like so. And set that value to movement offset. Now, there's something else here that I have to do. Because remember my mantra from the last video. Computers are dumb, phenomenally stupid, and they shall do precisely what you tell them to do. If I tell the computer to move the ball here, it will quite cheerfully do so. If I tell it to move it here, it will quite cheerfully do so. But I don't want it to move there. I want it to, at most, say, be able to move to here. Or maybe even just negative 14. That's as far to the left and as far to the right as I want the ball to be able to go. But I have to tell the computer that's what the limits are. The computer will not know all on its own. So what I need to do is I need to check to see if the X value of this vector is outside of a certain range. Now to do this, I'm going to use the superunit. Do I have to use the superunit? No. But the wires are going to get a little crazy on this one, which is why I'm going to use a superunit to try to keep things a little bit clean. And in all honesty, this here is a bit of a candidate for a superunit as well. I mean, if you think about it, this little chunk of logic here is very, very similar to what we did with the spaceship. Obviously, we also did the vertical axes, but the logic was the same between the horizontal and the vertical, and I'm repeating that logic again here. I want you to file that away for the next project. This is an excellent candidate for a macro, and using macros in this fashion as a substitute for commonly repeated actions. That's something that we're going to take a look at in the next tutorial sequence. We're not going to do it this time. It's a little bit too much new stuff being thrown at you, but I want to plant that seed in your mind now. This is repeated functionality. We've done it in 2 projects now. We need to start thinking about ways of not having to do this again. Okay, enough about that. Let's create a new super unit. Now, unlike the super units that we have done so far, we're going to do a little bit something extra here. So we're going to do the standard. Okay, here's the start. I believe I'm calling things finished this time for whatever reason. Usually I use end, but today I decided to go with finish, so we'll just keep it consistent. But more importantly, I'm going to need an input and an output vector. So on the input side of things, the value inputs, I am going to have an in vector and I'm going to have an out vector. Now to see how that's going to look up above, we can see now that in addition to the start and finish flow links, I have links for my vectors as well. So I've set my movement offset. I'm going to have it go to my super unit. I'm going to feed my movement offset, which is actually my new desired position at this point, into this super unit. And then what comes out I am going to feed into transform set position. Because whatever vector comes out of the super unit, in theory, is going to have its x values limited to the range that I specify. Now, obviously, I need to have those values, right? I need to know what is my x min, what is my x max. I could do those as graph level variables, but again, this is something that would make more sense as an object level. Because if I need to tweak the scene, if I want to make things bigger or smaller, my min, max, x values are going to change. So I'm going to create a min x and a max x. And as I just showed, I'm going to use 14 as my limiter. So what do I need to do? Now, first, I need to get the x off of this. So I needed a vector 3 get x. So I'm going to feed my input vector into this to get that x value. So first I'll handle the minimum x. What I'll do is I'll branch, and the true false is going to be, I'm going to take this x that I got, and I'm going to say, okay, are you less than my minimum x? Now, if you are, I am going to set the x value of my input vector. I warned you the wires were going to get a little crazy on this. I'm going to set the x value of my input vector to my min x. I'm not going to make the wires quite that crazy. I could drag the wire over there. Excessive wires bother me. This is purely a personal preference. There's no functional reason why you can't connect the wire from there. And at this point, I know I'm done. Because mathematically speaking, if I am less than my minimum x value, it is impossible for me to be greater than my maximum x value unless I've really screwed up my values. As long as min x is less than max x, I'm done here. And so after setting that x value, again, this needs to be chainable. And actually, no, it does not need to be chainable. And I'll show you why. So as I wiffle waffle back and forth on this, I don't want this chainable, and we'll see why in a moment. So done. Link that up. And here's why. Notice I can only have one variable wire going to a variable input. So what I need instead is my in vector to feed into my out vector. That does not mean it's taking the original value and putting in there. It's whatever the value of this variable happens to be, by the time I get to this point, that's what's outputted. All right, there we go. There's my min x. What about max x? So if it is false, meaning my x value is greater than my minimum x, well, I need to do another branch and ask the question if something is greater than. So this time I'm going to ask the question, oops, missed my click there, is x greater than my max x? If it is not, if the answer is still false, nope, then I'm done. And I don't need to keep going. If it's true, I need to do the same thing I did up here. Although, obviously, instead of setting it to min, I'm going to set it to max. And I also almost forgot to link up my vector. There we go. Try to make the wires as clear as I can. And there we go. There's its final form. So we come into our super unit. We follow the flow of execution. We branch. What are we branching on? I am branching on my x value being less than my minimum x. If this is true, I'll set the x to min x, and then I'm done. If it is false, if x is greater than min x, I do another branch on whether or not my x value is greater than my max x. If that is true, then I set my x to max x and finish. If that is false, I finish without changing anything. Now that's a lot of functionality there. Ideally, we probably should have stopped before we implemented the limiter and tested to make sure that our movement was okay. Because now if we have a bug, we won't know, is the bug in our movement code or is the bug in our limit x code? You see the problem there? If I run into an issue at this point, I don't know where the issue is. So all we can do hit the run button and pray there's not an issue. Oh, moving left and right seems to be fine. I stop at 14. And I stop at minus 14. And if I release, down it goes. Now there's one last little bit of logic on the ball that I want to implement, and that is resetting it to the top of the screen here. Because at the moment it's getting kind of frustrating for testing in that every time it falls off the screen, I've got to stop and restart. And especially once I go to start trying to test my goals down here, that's really going to be an issue. Also, the fact that this is not a trigger like it's supposed to be is also an issue for testing. So I'm going to fix these things real quick. First, I'm going to fix the goal. And I am going to change the collider to a trigger. This is important. Remember before, assuming now that I can get the ball to fall down in there. Yes? No. No. That is the one problem with this system. Good thing I have all my pegs and a game object that I can disable. See how it goes through now instead of bouncing and staying on the top? That's the behavior that we want. Turn my pegs back on. But what I want to have happen here is I'm going to create another cube. I'm going to drag this down so that it's just below everything. And then I'm going to set its X scale to something stupid like, no, not 30, 60, even dumber. There we go. Because I want there to be absolutely no chance, no possibility that the ball can avoid touching this. And I'm also going to mark it as a trigger. But now I have a problem. If the ball hits this trigger, I want the scene to reset. If the ball hits this trigger, I actually don't want the ball to do anything. The goal will handle that on its own. So how do I know the difference between this trigger and this trigger? Now, I could look at the object name. That would be a valid answer. A better answer, because you could very easily have a scenario of having multiple objects that will cause a scene to reset and have different object names. A better answer is to use the tag system. Currently, this is untagged. Also, pretend that you don't see this reset tag here because that's from my practice run. By default, you'll have down to game controller as a selection of pre-made tags. What we can do is we can either go to add tag from here, or we can go to project settings, tags and layers, and expand out our tags collection. And we can click on this little plus sign here and create a new tag. Now, upon creating that new tag, now, again, I forgot that I had already created a tag, so that is sort of messing up the video here a little bit. You would normally have an empty list here. And so if you create a new tag, call it reset, you're good. I'm going to ignore this tag right here. In fact, I'm actually going to mark it for deletion. And then what I can do is I can come back over here to the inspector and say, okay, reset cube, you now have the reset tag. And now I can use this to reset the ball. So I'm going to go into the ball. I'm going to go into my flow graph, make sure I'm at the top level here. And I'm going to add in a new event, just like we did for the meteors project. Add in, maybe not exactly like, this time I'm going to add an on trigger enter. Remember, enter, first frame that the collision happens. And then the first thing I'm going to do is I'm going to branch off of getting the tag. So I'm going to use the GameObject.compare tag block. And the tag that I'm comparing against is reset. Remember, this is a string. It is case sensitive. Capital R, lowercase r, different letters. As a common source of problems for new developers is not inputting their tags correctly, having case mismatch. So I'm going to compare the tag. I'm going to branch off of this. And if it is true, there's 3 things that I need to do. I need to reset my isTop variable. I need to turn kinematic back on. And I need to change my position. Now, the position, that's going to be a new variable. And again, I'm going to put this at the object level because if I change the field, I need to change this value. And I'm going to call this ball y start, which I just happen to remember is 15. So what am I going to do? Well, first I'm going to turn kinematic back on. So rigid body is kinematic. I'm going to set that to true. I am going to set the graph variable of isTop to be on. And then I need to set the transform position. Now, here's where we get into a little bit of a personal annoyance that I have with visual scripting systems. I can't directly set this y value to my variable. Instead, what I have to do is I have to create a new vector, XYZ, and I need to set the y value like so. It's an annoyance because it's not that many steps in code, but it is what it is. So I have turned on kinematic, I have turned my isTop flag back on, and I have reset my position. Let's test this and wrap up this video because it's definitely a bit longer than I would prefer. All right, and then remember to turn off full screen. That helps. Hit the run button. There we go. Let it rip. It bounces down. Falls off. And nothing happens. Okay. We have a bug. The first thing we're going to do is we're going to want to be able to monitor the flows. So let's just visually check. Do you see the error? It's right here. Compare tag self. We don't want to compare the tag of ourself. We don't want the ball's tag is the ball's untagged. It's not reset. And so if we watch this, see nothing, and there we go. It pulsed false. So it pulsed. We verified that it's working, but it's coming back false. Why is it coming back false? Because we're not checking the right game object. That is the collider. The other thing we collided with. That's what we want to check. There we go. You saw the big old pulse that went through there. And the ball's back up at the top, and I can drop it again. There we go. It's back at the top. I can drop it again. Excellent. It's working. We're almost there. This is getting the ball moving, especially because of that XY limit. That's probably the biggest chunk of work on this particular project. From here on out, it's relatively smooth sailing. We just got to get our goals working, do a little bit of material manipulation, set up our overall game logic to determine when we've won the game, and then that'll be it. We'll be done. As always, if you found this video useful, thumbs up would be appreciated. And if not, well, the thumbs down button is right next to it. I'll see you in the next video.